Just in case people are freaking out, I am here. I'm gonna start in the next like 3 or so minutes. Um, in the meantime, here's a bunch of notes. Have fun. But in a minute, I'll start and I'll go through every single thing. Same, Andrew. Same. Um, I have time. Here are all my notebooks. I don't know which one is probably most fun to look at though. Foundations was fun. I don't think there's a lot in there though. Coding theory maybe. But those are other videos which you should definitely watch. There's no reason. Oh no. Okay. No. There you go. Hi, Andrew. Hi, Bryson. And I know. So it is 7:50, so I will start, even though probably most of the people aren't actually in the class. It's probably alumni and cross-country runners and or my homeroom. Uh, the way this normally works is normally I'll have kind of like a spread of all the important notes that you're going to need for this test. Okay. So that's kind of what I have up here. We like over in blue, that was the first couple of lessons. In red, that was like day 2 and 3. Symmetry, we spent a couple of days on. Transformations, we spent time on. I'm hoping we have that in your notes because that's a lot to fit on one page. Um, and then the parent functions and transformations of those things. There's vertical and horizontal line tests. That's actually not going to be on this test. It's really helpful to know, but it didn't make it on this test just because it was so long. And then there's inverses. And I think I'm missing like one or two things, but we'll kind of go over it as we go over different questions. How am I already home? I live kind of close. Um, so I this is again this is going to be the start of this, and as we have questions, as I go over this stuff, I would like you guys to ask as many questions as you can, because that helps this whole thing. Okay. So if there's a little bit of a delay, but as you have questions, I'll do my best to read it, um, and I can kind of directly answer your question. Okay. It's also helpful to actually try and ask questions, even if you think you're not going to be able to word it correctly. That'll help you, I think, determine what you actually need to look over or what you're trying to ask. And that's going to be really helpful. Okay. So, there are the notes. I'm actually on a different page because this is from my juniors, so I need to go down here. All right. Um, okay. So yeah, this is the right one. All right. Here is just a regenerated version of the test. I yeah, hopefully wrote a 300. So here's another regenerated version of the test. This I did not give this to you. I actually changed a couple of things. I actually made this a little bit shorter. I took out a couple of like repeated questions or questions I had three of, just to make this go by maybe a little bit quicker. And I might still modify it just a little bit. But overall, it's the same type of questions. Okay. Um, so we're gonna go over this as thoroughly as we can, and still kind of get through this in a relatively decent time. Okay. So first couple questions. This has to do with the distance formula as well as just being able to label points. That was one of the first things we did. So this says label the points on a given graph. Right. So let's do that first. All right. So this point right here, that is 4 comma 5. Right. It's the x distance and then the y distance. This point down here is 3, 0. So that in and of itself, I believe is worth 1 point. Okay, so just being able to label points, that's worth something. Okay, and then we have to use the distance formula, which I'm going to write over here. So for 2 points, x1, y1, and x2, y2, we have the distance between them being x2 minus x1 squared plus y2 minus y1 squared. All right. So we have 2 points. We have 4, 5, that can be x1, y1, and we have 3, 0, which can be x2, y2. If you want to label it, it's never a bad idea. Right? This can be x2, I think I said. I'm glad I have 2 Andrew Dolans. So we just plug it into that equation, right? So d is equal to the square root of 0 minus 5 squared. I'll keep this really consistent. X2 minus x1, so 3 minus 4 squared plus 0 minus 5 squared. Okay, if we do that, 3 minus 4 is -1. -1 squared is 1. So we get 1 plus -5 squared is 25. So we just get the square root of 26. And that is as simple as I can get. So that's our answer. So that's find the distance. That's also a couple points. I have to go back and look at what I actually assigned to that, which we can do in a second. And that says find the midpoint. Midpoint is just averaging the x's and averaging the y's. So the midpoint between 2 points x1, y1, and x2, y2 is just the average of the x's and the average of the y's. That's a y. Okay. And that's going to be an ordered pair. All right. So what we have to do is add together the x's. So 4 plus 3 divided by 2. And 0 plus 5 divided by 2. Which is going to give us 7 halves and 5 halves. And then that's our midpoint. Okay. So 3 parts of the problem: labeling the points, finding the distance, and finding the midpoint. Yes. Yeah. So for the distance formula, you square all the numbers. You're adding the numbers inside. All right. So up here, you're subtracting the x's together, and you're subtracting the y's together, and you're squaring each of those individual numbers. You're adding them together, and you're taking the square root. Okay. This has to do with Pythagorean theorem. All right. we have, I'm going to do a little bit of drawing. Yeah, this will show up. Okay, so x2 minus x1 gives us this distance in green. y2 minus y1 gives us this distance in green, and that's a right triangle. Okay, so let's say A is down here, B is on the side. So we have A and B, and we need C. So if you know the Pythagorean theorem really well, you know that a squared plus b squared is equal to c squared. So if you solve for D, right, that's C. If you solve for C, that's the distance we're trying to find. You would get C is equal to the square root of a squared plus b squared. That's where that comes from. So then how do you get a 1 plus 25? Wouldn't it be just 26? Yeah, it is. 1 plus 25 is 26, right? So down here, 3 minus 4, that's negative 1. I'll add in a step. And we have to square that. Plus negative 5 squared. That's equal to 1 plus 25, which is rad 26, which is what we got. Okay. If that confuses you, just let's do this next one, and hopefully it makes a little bit more sense. All right. Top point is 5, 1. Bottom point is 4, negative 3. All right, so that's the first part. Then we need to find the distance. The distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. 4 minus 5, that's negative 1. Negative 3 minus 1, that's negative 4. So this is square root of 1 plus 16, which is just rad 17. Then we find the midpoint. Midpoint, we're just averaging the x's and averaging the y's, so we get 5 plus 4 divided by 2, and negative 3 plus 1 divided by 2, which is 9 halves, and negative 1. Okay, so 3 parts to those problems. There's labeling the points, there's finding the distance between the points, and then there's finding the midpoint between the points. All right, I'm going to scroll down a little bit. Or not. There it is. How much is that problem worth? Let's actually look. Okay, so this is the answer key to my junior's test. Those problems were worth a total of 4 points, right? So 1 for labeling the points, 2 for finding the distance, and then 1 for finding the midpoint. Okay. Identify the center and radius of each. So this is the equations of circles. So the equation of a circle with center HK and radius R is x minus h squared plus y minus k squared is equal to r squared. Okay, and that's really what you need to know here. So for number 3, our center is negative 3 halves, comma 2 rad 53. And then our radius, so that's the center. Our radius is, so our radius squared, let me put it that way. R squared is equal to 12, so R is equal to the square root of 12. I'm not worried about you simplifying that. If you just get there, you're fine. If you wanted to simplify it, that'd be 2 rad 3. Both work, though. For number 4, the center is 14, 16. The radius squared is 1, so the radius is 1. I think both those are worth 2. For number 5, you're given a center, so you're given an HK. And you're not really given a radius, you need to find out what the radius is. Okay, so in this example, it's not necessarily the example I'm going to give you. But area is equal to 12 pi. So if area is equal to 12 pi, you should know that that's the same thing as r squared times pi, or pi r squared. So again, r, I don't know why they're the same as the one above it. R squared is equal to 12, so r is equal to rad 12. Okay, so we need to write an equation with this r and this center. So we get y, I'll do x first. We get x minus negative 15 squared plus y minus 9 halves squared is equal to rad 12 squared. So if we just simplify that, x plus 15 squared plus y minus 9 halves squared is equal to 12. And that would be your answer. I think that's worth 3, if I remember right. So that's the equation of the circles. I'll pause there for a second. I'll give like a 30-second pause and then just make sure no one has questions over it. For the radius, do you use the simplified version? I'm guessing you mean like r is 2 rad 3. It doesn't really matter. In fact, it's probably easier to keep it as rad 12, because when you keep it as rad 12, when you square that, it just becomes 12. Okay, whereas 2 rad 3 squared, there's a little bit more thinking involved. That's 2 rad 3 times 2 rad 3, which is 4 times 3, which is 12. There's just a couple more steps. So like I would keep it unsimplified, especially for number 5. I'm not worried about you simplifying this part. Usually it's okay to just leave it unsimplified. We'll work on that later. That comes back sometime in chapter 2, I think. Well, if it was like square root of 4, I mean, it's probably easier just to make it 2. It's the same thing though. If the radius is the square root of 4, then the radius squared, which goes in the equation, is just 4. It's the same thing. It's whatever way you feel more comfortable with. All right, let's move on to the lines. Write the equation of the line through the given point with the given slope. I want to write down the equations of a line. I will take either one of these. So I'll either take mx plus b, right? That's the slope-intercept form. Or I'll take point slope, which in my opinion is way easier on most of these, which says y minus y1 is equal to m times x minus x1, where y1, sorry, where x1, y1 is a point and m is your slope. Okay, so for example, in number 6, we want the equation of the line through -4 with slope 3/4. So we know m, and we have a point. So in my opinion, it's probably easier to use point slope form. And we can label these, and it might make it easier to at least understand. We have an x1, y1, and we have an m. So all we do is we plug it into that point slope form. So we get y minus -4 is equal to m x minus x1, which is -4. So we get y plus 4 is equal to 3/4 x plus 4, and then that's it, right? This is in point slope form. That's an equation of a line, and I'm okay with that. Okay, That's one way to do it. You can also do it the other way, where you use y equals mx plus b. Okay, we have m, and we also have an x and a y. Okay, y is -4, m is 3/4, x is -4, and we need to solve for b. So this is why I don't do this, because it takes more steps. So we get -4 is equal to -3 plus b. Add 3 over. We get 1. And then our equation is y is equal to 3/4 x plus 1. These are both the same thing. If we simplify this one in blue, we get the thing in red. So an equation of a line does not have to be in y equals mx plus b. No, I don't care. Because you guys have been doing y equals mx plus b for a very long time. So I'm assuming you know it. So like you get that, but there's an easier way. In terms of like actual pre-calculus, it's normally better to know just how to find a slope. But an equation of a line is really important later on. So being able to do both is helpful, but being able to do one really well is also good. And if you use point slope form, you can get to slope intercept form, right? If we distributed the 3/4, so we get 3/4 x plus 4 times 3/4, so we get plus 3, and then subtract the 4 over, we get the same thing. Wait, no we don't. This should be a -1. I wrote this wrong. -4 plus 3 is -1, not +1. So I like that. That's why I use point slope form, because I can go directly to any other form I want to. IXL 100% glitchless rando. There's no rando. It's just going to be 100% all the way through. And I don't know yet. Hopefully Thanksgiving. As long as other people do alongside me. And we get some donos. But regardless, write an equation of the line through the given points. So now we're just given 2 points and we don't have a slope. So we need to find slope. So we need to find m, which is y2 minus y1 over x2 minus x1. And I'm going to label these because that'll make it easier later. So y2 is 3, y1 is 1, x2 is 1, x1 is 0. So we get 3 minus 1, that's 2, over 1. So our slope is just 2. I had this on in the background doing my homework, but now I'm done and I can't stop watching this. So weird. Yeah, a little bit. So we get slope is equal to 2. So then we have a slope and we have points. So point slope form is probably going to work the best. And we have an x1 and a y1 labeled. So I'm just going to go ahead and do that. So y minus y1 is equal to m times x minus x1. So this works. If you do slope intercept form, you could use either one of the points. Let's use this one, right? So y is equal to m times x plus b. So 1 is b, and then you just plug it back in. Right, so either one of those boxes work. And actually, there's another way to do point slope form too. You could do y minus 3 is equal to 2 times x minus 1. All of these things boxed are possible answers. I will donate my presents if you complete IXL 100% by next week. That's not happening. I can promise you that. I need a lot of time. Apparently it takes like an hour and a half to get through like preschool. And if there's 12 grades after that, I need a very large amount of time. It's more of just a gimmick. I don't really want to do it. Write an equation of the line described. So we're talking parallel and perpendicular. Parallel. Can you do either slope for? Can you do either point for point slope? Yes. Right. So this is the x1 y1 point, and this is the x2 y2 point. So y minus y2 instead of y minus y1. They both work. Okay, parallel. So for parallel lines, I spelled that wrong. The slope of line 1 is equal to the slope of line 2. For perpendicular, m1 is equal to the negative reciprocal of m2. So we just have the same type of problem. So our, oh no, okay. This one doesn't count because this is an undefined slope, right? So this is just parallel to x equals 0. So if we just draw this, our line is this, right? It's x equals 0, looks like this. And if we're going through 1, negative 1, parallel to that line, we have to get this line, which is just x equals 1. I won't give that to you. It's kind of defeats the purpose, but that's the answer. Bottom line is you keep the same slope. That's what I want you to know. All right. Number 9, through negative 1, negative 5, perpendicular to y equals negative 1/8 x. So if this is the slope of the line and we want to be perpendicular to it, the slope of our line is going to be that thing flipped in the positive version of it. So, or the negative version of it. So it's just 8. So it's positive 8 over 1. So then the equation of our line, again, if we just use point slope form, we get y plus 5 is equal to 8x plus 1. I'm going to leave it at that. I'm hoping we can get it in slope intercept form. Okay, so that's part 1. That's just lines, distance, and circles. Part 2 is where it gets a little bit trickier, or at least just a little bit more tedious. Not tedious, just more of it. State if the given functions are inverses. So when we have inverses, like the definition of our inverse, two functions f and g are inverses. If f of g of x is just equal to x. Okay, so what we need to do is we need to compose these two things together. So you could either do g of f or f of g, both work. So let's do g of f. So that's g of this whole thing. So this is negative 2 times the input, which is now the cube root of negative x minus 2 over 2. And then minus 2 on the outside. That should be cubed as well. So the cube undoes the cube root. So we get negative 2 times negative x minus 2 over 2 minus 2. 2 times anything over 2, they cancel. And we're left with the negative on the outside. So we get negative x minus 2 over 1 now, if you want. And then minus 2, which is the same thing as positive x plus 2 minus 2, which is just equal to x. And this says, yes, they are inverses. Can I do a problem for parallel? It's not the same as perpendicular. Let's say instead it gives the line y is equal to 3x plus 2 or something. It would be, our new slope would be 3. So we'd get y plus 1 is equal to 3 times x minus 1. And that's what, so parallel slope is easier than perpendicular slope. Yeah, what he said. Okay, so that is verifying, right? So this is verifying. I'm giving you two functions, and you need to tell me if they're inverses of one another. So that happens if when you compose them, it's just equal to x. If it is not equal to x, say it's like negative x or 2x or x squared or another whole nother term, they're not inverses. Okay. Number 2 says state the domain of the given function, then find the inverse, then state the domain of the inverse. Okay. I might take this domain piece out just to take away a little bit of time. But the domain of this n can be anything. There's nothing illegal that we can plug in here. So it's just all real numbers. Okay. And I want to do this in, to me, the way that makes most sense and the way that might help most people. So I'm just going to list operations on n. And then we're going to use that list in order to get the inverse. So if we like hyper focus on this n, the first thing that happens to n is we add 2. And that gives us n plus 2. The first thing that happens to that n plus 2, right? So now we're dealing with this whole thing, is we take it to the 5th power. So that gives us n plus 2 to the power of 5. And then we add a negative 2, so we subtract 2. Nick, I'll answer your question in like 2 seconds. Let me finish this part first. So that gives us n plus 2 to the 5th minus 2, which is the same thing as we have up here. It's just in a different order. To find the inverse, we reverse that order. And invert the operation. So the first thing we do is this last step, and we invert the operation, so we add 2. So this gives us n plus 2. Then we do the inverse of taking something to the 5th power, so 5th root. So we get the 5th root of n plus 2. And then we have to do the inverse of add 2, so subtract 2. So that gives us the 5th root of n plus 2. And then on the outside, minus 2. And then that's our inverse. Hi, Cole. So the domain of this, and again, I'm probably going to take this out for your test. The domain of this is also all real numbers. Because we can plug in anything we want for n. If this were an even root, so say it was just the square root instead of the 5th root, then the inside couldn't be negative, which would change that domain. Okay, I'm not super worried about that for this test. Yes, we should know what domain is. We should be able to tell kind of what the domain happens to be. But in terms of like, I would rather you be able to find the inverse and then we can talk through the domain as opposed to knowing both. Okay. I might keep it in. It might show up somewhere a little bit easier. Like I might ask you what the domain of 1 over x or something is. Um, Again, domain is just all the legal inputs. It's not meant to be crazy hard, right? So if I just had the square root of x and I asked for the domain of this, so what is the domain of square root of x? We can't take square roots of negatives, so the domain here would be x is greater than or equal to 0. Yes, most of the points is finding the inverse. It might still show up in the directions, but I might just make it worth less points. Right, the domain of 1 over x, right? We can't have a 0 in the denominator, so this domain is all real numbers except 0. Can you show an example doing number 2 on chapter 1, test part 2? I'm just going to do this is a regenerated version, okay? I'm just going to stick to this. So everything that is on that is also on this. It's just a different modified version. Right? So going on to the going on to these questions. Couple things I'm asking. Identify the parent function, describe the transformations, then sketch the graph. So 3 different parts. And I'll show you how I graded these here in a second. The parent function here is square root of x. Easy enough. That should be obvious, right? So this one over here. Is absolute value of x. Okay. And then we're just listing operations. Okay. So this minus 2, that's telling us to go right 2. What's up, Chuck? Okay, so that minus 2 on the inside means go right 2. This minus on the inside, right, we're making the entire input negative. So that means we're reflecting around the x-axis. Sorry, the y-axis. So reflect around y. Okay, so we take our parent function, square root of x, we shift it right 2, and then we make it go the other direction. So our function looks a little bit like this. Sorry, I keep pausing because I'm trying to read what's happening. But I also want to give people time to like answer or ask questions. All right. So number 4, if you don't want me to stop as much, I won't. I'm just trying to give time for people to actually try it too. So number 4. Okay, this plus 3 means we're going left 3. So plus 3 on the inside means goes left 3. This negative means flip upside down. So we're going to have our parent function, absolute value of x, shifted left 3, and then it's upside down, so our function looks like this. Doesn't have to be exact. I can't draw very well on this pad, but that's what it looks like. So I want to put these rules out. Okay, so transformations and reflections are what I'm requiring you to know. So for any parent function f of x, we get vertical shifts when we are adding something to the outside, right? So plus c, that's up c, minus c, that's down. We also have horizontal shifts. Vertical has to do with the outside of parentheses. Horizontal has to do with the inside of parentheses. And then it's always the opposite of what you think horizontally. So f of x minus c means we go right c units. F of x plus c means we go left. Say there's a square root of x, but there's a plus 3 on the outside of the square root. Does that mean it's still left 3? No, if it's on the outside of the function, it means you're going up or down. So square root of x plus 3. Like this, right? Where that plus 3 is on the outside. That would just be this. Okay? I'm going to erase that though, so I don't want to confuse people. But outside means up and down, inside means left and right. And we also have reflections. Okay, reflections means going around a certain axis. So we have a vertical reflection. So this is x-axis. Right, around the x-axis would be vertical. That's negative f of x. So that's making the output negative. And then there's horizontal, which is about the y-axis. And that's when we're making the input negative. All right, so that's the transformation stuff in a nutshell. That's just all those notes in one place because they weren't up above. All right, going to number 5 and 6. Okay, so on the test I gave you, I think there were 3 of each of these. I'm making it 2, again, just to save a little bit of time. And on this, there are a couple of directions. There's identify the parent function, describe the transformations, and then write an equation. So 3 different parts. So number 5, that parent function is the cubic. That's not the cubic. And I'll explain it in 2 different ways. You only need to explain it in one. Okay, this cubic is shifted left 3 and up 3. Right, so left 3 and up 3. And it's right side up. There's no reflections or anything like that. So our equation is going to be f of left 3, so plus 3 on the inside, and up 3, so plus 3 on the outside. So if we write that as just x cubed, that's going to be x plus 3 cubed plus 3. You want us to write cubic, or do you want to... It's... this is fine. If you want to write cubic, that's fine. I'm more interested in you knowing what cubic actually means than like the name of it. So like personally, I'd rather you write x cubed, but if you want to write cubic, that's fine with me. So long as you're right when you actually write the equation. Okay, so if you say cubic and then you have like a square root over here, then that's not right. But that highlighted thing, that's your end answer. Number 6, the parent function here is x squared, so quadratic. This is shifted down 2, and it's upside down. So down 2 means we are subtracting 2 from the output. Upside down is a vertical reflection, so we just make our output negative. So we get negative x squared minus 2, and that would be our answer. So when you do horizontally, we need to put whatever plus or minus inside the parentheses on both sides. By both sides, I'm assuming you mean this and this. Yes. You don't need to do the f of x stuff. I'm not, like, it's fine if you're able to. If you don't know what the parent function is, this is a good substitute. But I'm really focused on the stuff that's highlighted. If the f of x stuff confuses you, just stick with this. That's kind of the important part. All right. So those are the transformations. Let's move on to the combinations. F plus g of x, that just means we're taking f of x and we're adding g of x to it. So that's just substitution now. Right? So f of x is x squared minus 6x minus 9, and we're adding x minus 3. So then we combine like terms, we get x squared minus 5x minus 12. That would be our answer. So we won't get points off for getting the f of x stuff wrong. I didn't say that. I just said if it confuses you, don't do it. If it helps you, then by all means, go ahead and do it. But if I have to guess which answer you mean, I'm going to take points off. Only if it helps you should you use it. F over g means f of x over g of x. And this is going to require one extra step, right? So we know f of x over g of x is x squared minus 6x minus 9. We know g of x is x minus 3. I'm going to give you something where you have to factor and cancel something out. Okay, so what I mean by that is if we factor the top, we get x minus 3 times x minus 3. If that's confusing to you, remember we need factors of -9 that add up to -6. So minus 3 minus 3. That's not right. That should be a plus 9. Okay, this is a bad example. So you can't actually factor this, right? Yeah. So this won't work. So I'm going to just take a second and change this. Sorry. Let's say that, just for this problem, let's say that f of x, I'll do this in a different color too. Let's say f of x is x squared minus 6x plus 9. I miswrote this. And g of x is still x minus 3. So f over g, that's x squared minus 6x plus 9 over x minus 3. And what I was trying to say is that I'm going to give you something where you have to factor the top. Right? So if you factor the top, you need factors of positive 9 that add up to -6. Those factors are -3, -3. So we get x minus 3 times x minus 3 over x minus 3. We can take out a common factor between both of those things, and we're just left with x minus 3. So there will be some kind of factoring involved in this. Easy factoring, but factoring. I hope I didn't confuse people. When I type this in, this is like one of like 3 things that I actually type, and I did that one wrong. Will you wait there for just 1 second? Sure. I got a point off on that one. Yes, you did, Mateo. Yes, you did. I'm just doing this myself too. That's fine. Yeah, I'll pause there for a second. I'm going to mute myself too. Um, yes, you can retake it. The problem, one of the reasons I don't like to do this, like I like doing this, it's I think it's helpful for guys the night before. But I think a lot of guys think that just because they watch this, they're gonna do well. That's not necessarily the case. Do you want me to turn in the test review? No, you don't have to turn in the test review. That's just for you. Okay, but the reason I do this is so people have a second chance to see me do this stuff. But just because you're able to kind of follow along or you watch this doesn't mean you're actually prepared. Ideally, you actually like study for the day of the practice test, and then you like you're prepared for that. You take the practice test, and then you're even more prepared for the test. So the practice test is supposed to kind of help you see what you need to study, and then this is supposed to kind of help just make sure you did it right. I don't know where my stylus went. Hold on a second. Okay. Um, Factoring is light work. No, yeah, the factoring is not illegal. Easy factoring is very easy. Yeah, I have committed numerous war crimes if factoring is a war crime. I don't know. Okay, so moving on. F times g of x. So we're gonna take f of x. I need to write this down, so I'm gonna write it down here. X squared minus 6x minus 9, and then times x minus 3. So this is asking for multiplication, so we need to do kind of like long-term FOIL. So I'll do this in a couple of different colors so we see it. X squared times x, that's x cubed. X squared times negative 3, that's negative 3x squared. Negative 6x times positive x, that's negative 6x squared. Negative 6x times negative 3, that's positive 18x. And then negative 9 times x, that's negative 9x. Negative 9 times negative 3 is positive 27. And then all we have to do is combine like terms. So we get x cubed minus 9x squared minus 9x plus 27. And that's it. All right, f of g of x, this is where we're composing them together. So this is f of g of x. So this is f of x minus 3. So x minus 3 is our input into f, which just to put it up here, we get... Right, so f says we want our input squared. We're going to subtract 6 times our input, and then we're going to subtract 9. So if we just follow that, we're going to take our input and square it, minus 6 times our input, minus 9. And then we're just going to combine like terms and simplify. So x minus 3 squared is x squared minus 6x plus 9, and then minus 6x plus 18, and then minus 9. If you are confused, this comes from foiling x minus 3 squared. This comes from distributing the negative 6, and that minus 9 was just there. I would consider to I would consider doing an ACT review. I just don't know how that would work. If we combine like terms, we get x squared minus 12x plus 18. 18. There we go. Why does the 0 change it so much? Oh, again, this fog, this 0 is kind of like of, so f of g of x, it's the same thing as this. G of f of x is the same thing, it's just backwards. So we're taking g of f, so we're taking g of x squared minus 6x minus 9, which is equal to that thing, our input, minus 3. So we get x squared minus 6x minus 12, and that's our answer. It is exactly like inverses. Inverses and this are kind of the same thing. We're just not trying to undo functions here. We're just trying to compose them. All right, so that is the function composition and combination. Number 12. So how much do I have left? Okay, not much. All right, we're doing good. Okay, so right triangle. Let me draw this, but like in a better color. There we go. Do that. All right, so for a right triangle with hypotenuse C and sides A and B, we have a squared plus b squared is going to be equal to c squared. All right. So what we're trying to do here, determine whether or not the following 3 points are vertices of a right triangle. What we need to do is we need to find an A, a B, and a C. So we need to use the distance formula quite a bit. So we need to find the distance between these 2 points. So x1, y1, and x2, y2. And then we also need to find the distance between x1, y1, and x3, y3. And then we need to find the distance between x2, y2, and x3, y3. Okay, so there's 3 distance formulas that we need. And that's going to determine our A, B, and C. Then we plug it into that Pythagorean theorem and see if it holds true. So let's do distance between, and I'll write all these out, which I would recommend doing just to help you. So let's do x2 minus x1. Yeah, I'll just do this. No, I'll write it out. I'll make this really, really obvious what I'm doing. Okay, so we need that. We need the distance between x1 and... We need the distance between 1 and 3. So x3 minus x1 plus y3 minus y1. And then we need the distance between 2 and 3. Orange. So then we're just plugging numbers in, and that'll help us. All right, so for red, that's the square root of x2 minus x1, so 4 minus 2 squared plus y2, so 7 minus 4 squared. 4 minus 2 is 2, 2 squared is 4. 7 minus 4, that's 3, 3 squared is 9. So square root of 13. Okay, for blue, that's x3 minus x1, so 8 minus 2 squared plus 2 minus 4. 8 minus 2 is 6, 6 squared is 36. 2 minus 4, that's negative 2. Negative 2 squared is 4, so this is square root of 40. And then the same thing, right? So x3, that's 8. 8 minus x2 plus y3 minus y2. 8 minus 4 is 4. 4 squared is 16. 2 minus 7 is negative 5. Negative 5 squared is 25. Oh, and now I can't add. So 25 plus 16, it's 11. 41. I got there. All right. So now what we need is we need to plug these things into A, B, and C. C has to be the largest. So that is this guy right here. That's C. We can name blue A. We can name red B. This is a 7-step problem. Kind of. It's really like a 4-step problem, but 1 step is really long. Okay. So, I'll do it off to the side. So A squared, so rad 40 squared, plus B squared, rad 13 squared. We need to see if that is equal to C squared, which is rad 41 squared. So this was really actually easy. Just 40 plus 13 equal 41. It doesn't, therefore not a right triangle. So again, we find the distance between each pairs of points. 1 and 2, 1 and 3, 2 and 3. We label the biggest of those to be C. The other two are A and B. And we check to see if the Pythagorean theorem actually holds true. So that's what we did over here. Right, so 40 plus 13 is not equal to 41. That's a question mark up above. So because 40 plus 13 isn't equal to 41, those points are not vertices of a right triangle. Okay, and I think we have like 2 actual problems to do. Okay, so the last 2 are a little bit long too. Symmetry. Okay, 3 types of symmetry. There's y-axis, there's x-axis, and there's origin. That just doesn't show up good. We'll do this. Okay. For y-axis symmetry, And I explained this during class. So y-axis symmetry, if a point xy exists, then the point negative x comma y also exists. So what we need to check if f of x is equal to f of negative x. If that's true, if those two things are equal, then it's y symmetric, right? So f of x, that's this thing. F of negative x is equal to negative 4 times negative x over negative x squared minus 1. That's just equal to positive 4, right? Negative 4 times negative x is positive 4x. Negative x squared is just x squared, and then minus 1. Okay, this thing is not equal to f of x, right? We're missing a negative, so it's not equal to it. Therefore, this is not y symmetric. For x symmetry, we have to check. So for x symmetry, if the point xy exists, the point x negative y also exists. So we need to check if f of x is equal to negative f of x. Right, so negative f of x is negative 4x over x squared minus 1. And again, those negatives cancel out. So this is just equal to 4x over x squared minus 1. That is not equal to the function, right? Again, we're missing a negative. So this is not x symmetric. Okay, for origin symmetry, we're testing kind of both at the same time. So we need to test if f of x is equal to negative f of negative x. For x-axis symmetry, you just put a negative where the y is. No. We're taking like so I guess I could write it like this. That might make more sense. Right, if the inside of these parentheses is f of x, we want to make that negative. And when we do that, the negatives out front just cancel out. Okay, for origin symmetry then, we need to see if negative 4 negative x over negative x squared minus 1, we need to see if this is equal to the original. So if we do this, the negatives up top, they cancel, so we're still left with negative out front. Negative x squared is just x squared. And that's just equal to negative 4x over x squared minus 1. This thing is equal to the original. Therefore, this is origin symmetric. Okay, so not y, not x, but it is origin symmetric. The things to know here are these things highlighted in green. Okay, so those are really important. Numbers 14 and 15. So I'll leave that kind of up here while I explain this. Nope. There we go. Okay. So number 14 and 15, first of all, there's only going to be one of these. So I will cancel one of these out. And chances are there's only going to be a couple of, like, it's probably not going to be x to the 5th. Okay, so this one probably won't be on the test. Okay, you'll have something that looks like this. All right. I can't do that on this computer. I don't have the calculator installed on this, so I can't show it to you. But what I can say is like how to get there, right? So so we graph it. We put all of this into y1. We hit graph. We hit second, and then calc. That gives us a menu. We have to find the zeros. We have to find the minimum, and we have to find the maximums. Right? Each one of those asks left bound, right bound, and guess. Okay, so for the left bound, right, so let's say I have a 0. I'm trying to find the left-hand 0. Okay, so on a calculator, we hit second trace, we hit 0. We put our cursor over here. That's left bound. We put our cursor over here. That's right bound. And then we guess somewhere in the middle, and that'll give us the 0. And we have to do the same thing for this guy. Okay. Then we do the same thing for maximum in this case. We hit second trace, but this time we hit maximum. We do left bound, right bound, and then somewhere in between. And then that'll give us our maximum. Okay, I'm hoping we went over that a bit, and this is like a 2-point problem. I just want us to be able to do this on a calculator as well. All right, and there's only going to be one of them. All right, so on to the last question. So when we see this, just like all the other like longer problems, so symmetry and the right triangle problem, you just need to kind of pause a minute and give yourself a list of things to do. All right, so split it up into the easiest components you can. So for what I would think is we can start. I have no good highlighter colors. We could start by finding f of x plus h. Right, that's right here in the problem. We know what that looks like. We've seen that a lot and we've done it. So let's just find that. Right, so if f of x is -3 times our input squared plus 2 times our input minus 4, this is -3 times our new input plus 2 times our input minus 4. And then we just expand everything as much as we can, right? So x plus h squared, that's x squared plus 2xh plus h squared. Then we distribute that 2. And that -4 is just a long, right? So then we distribute the 3. And we get all that. Okay, so we did that thing, and then it's telling us to subtract f of x from it. Okay, so if we maybe make that another step. Right, so that's all f of x plus h, and we want to subtract f of x. And when we do that, I'm going to rewrite this, but then simplified. You don't have to do this. Things cancel, all right? So -3x squared cancels +3x squared. 2x cancels -2x, and then -4 cancels +4. And what we're left with is -6xh minus 3h squared plus 2h. So that's f of x plus h minus f of x. And then that thing all over h is going to be equal to that thing that we just found all over h. The chance I actually get this right on the test is next to 0. Again, if you're just careful with what you're doing, and I'm showing probably a lot more work than you need to show, or at least a little bit, it's just a step-by-step process. There's nothing, you know how to compose two functions together. You know how to combine functions, right? You know how to do this part. And then you should know how to subtract other parts. Okay. This is just the test you took. I'm making it a little bit smaller. Okay. But once we are here, you should see that there's an h in common up top. Right, so we factor that out, and you should notice that h over h, that just becomes 1. So our entire answer is just negative 6x minus 3h plus 2. It is just a lot of writing, okay? Don't confuse a long problem with a difficult problem. Those aren't necessarily the same thing. F of x plus h is easy to find. Subtracting other terms should be relatively easy. And then realizing that an h is in common, which there will be, shouldn't be very difficult either. Okay, so that's the entire test. The only problems I'm not able to do right here are these two. Okay. So what I'm going to do now is I'm going to scroll back up to the top. I'll slow scroll through. And as you have questions, just let me know. Okay, so let's say by 9:10, if there's no questions, I'll shut it down. But if you have questions, ask them, and then I'll do my best to answer. So I'm going to mute myself. I'm going to scroll back up to the top and slow scroll down. And by 9:10, if there's nothing left, we'll call it. Can I explain f of g again? Yes. I want to give people a second to kind of look at these things again real quick. I don't know why I do this, because you can just go back and rewind. So let me do that now. All right. So I'll make up a problem. Let's let f of x equal 3x squared minus x plus 1. And let's let g of x equal 4x plus 2. Okay. F of g of x, well, let me start here. This thing, right, this f, this says that we take our input, we square it, and then we multiply it by 3. Then we subtract our input, and then we add 1 to all that. This x here tells us what our input is, right? So in this case, the thing that I have written, the input is just x. So when we're composing two functions together, right, if we have f of g of x that is this new function that's a composition of two, right? So this says that we are taking g of x as the input into f. You're welcome, Landon. Okay. So our new input into f now is g of x, which is the same thing as 4x plus 2. Okay, so we have this function f that tells us what to do with our input. And f tells us we are taking our input, we're squaring it, or multiplying that by 3, we're subtracting our input again, and then we're adding 1 to all that. Okay, so if we do that, I'm going to have to actually write this out. I'm hoping we can foil. That's why I'm going over this decently quick. Okay, so the composition actually happens like here, right? Everything else is just trying to combine like terms. And again, when we're composing two functions, it's helpful to know what function notation actually is. Right, so if we still have this function, right, no matter what I plug in here, let's do like box, right, f of our input, f of box, that says 3 box squared minus box plus 1. And plug whatever you want into the box, and that's what we do, right? So in this case, our box, the thing inside of that, is this 4x plus 2. And all you're doing is inputting 4x plus 2 into each one of those boxes. And then we FOIL, we simplify, we combine like terms, and then we're done. Okay, so I'm hoping that explains it a little bit better. So I'll stay here for a second. If there's no questions in the next couple minutes, though, then I'll shut it down. Do I have to do that work that everyone else did in class? Yes. Hi, Mason. So I'll shut this down at 9:15. So if there's no questions between then and now, then we'll be done. That was a stupid question, Mateo. No, it's not a stupid question. I think that's fair. I kind of left him in class or I didn't leave him in class. As we were leaving class, I'm like, hey, do this. So he didn't really get a chance to do it. But yeah, I don't. There's no mercy here. Will we be able to see this after it's done streaming? Yes, I believe so. As long as you have um, that link, I think you should be fine. I've also I think I figured out how to get it up immediately. I just have to end stream on the YouTube side. Normally, I just kind of shut everything down, and I don't think they like that. So, yeah, it should show up pretty quick. But also, if you just keep this tab open, um, it should also be pretty quick. I think a mistake though is to stay up all night stressing about it. I would rather be well rested. Like, yeah, go over a couple problems, but also don't. I would rather you sleep than not. Hi, Gianni. I've been doing this since I got home, and then I gotta do splits after this. I don't know if Joe's still here. Apparently there's only 5 people in here, and like 3 of them don't actually have my class, which is funny. 55 minimum isn't bad. If you can get a, oh, there you go. Okay. Let's see the setup. Nah, I'm good. I'm tired. I'm Everything's everywhere. There's no organization to my desk. Nah. 'It's 9:15. We've been going for an hour and a half. So I'm gonna shut this down. This will be up as soon as I end it. So if you need to look through a couple things, go for it. Again, I think it would be a bad idea to just like stay up all night watching this only. If you do continue to study, I would go back to where the questions are blank, copy them down, and then try and do them on your own. I think that's the best use of your time right now. If you can't, then listen to me do it. But I think a better practice would be to try and do it without help. Okay. But again, don't stay up until 2 a.m. trying to do all this stuff. That would not be helpful. All right. So I'm going to shut this down. I will see you guys tomorrow. Thank you for watching. And yeah, good luck. So I'll see you guys tomorrow.